Hello everyone. Today I would like to introduce you about IR 4.0, which is Industrial Revolution 4.0 pillars. The so-called IR 4.0 reshapes our life, works and the way to relate to each other, while people strive to understand and benefit from technology changes. A challenge that is irreversibly transforming mankind, involving all factors from all economic sectors, regions, cultures worldwide to keep the process human-centered. Connectivity and networking of people from all over the world by the internet and mobile devices, processing speed, access to knowledge, storage capabilities, and the impact of destructive and collaborative innovation in different fields, such as augmented reality, system integration, cloud computing, big data, Internet of Things, 3D printing, cybersecurity, autonomous robots, and simulation. Interdisciplinary approaches, fusion of technologies across the physical, digital, and biological worlds. The first pillars of IR 4.0 is augmented reality. Augmented reality is an enhanced version of the real physical world that is achieved through the use of digital visual elements, sound, or other sensory stimuli delivered via technology. Virtual augmented reality, they can be seen as an emerging form of experience in which the real world is enhanced by computer-generated content. The reality is usually enriched with elements like audio, video, tactile information, graphics, and GPS in order to create to the user the perception of a real world. During the learning process, these technologies assist students to better and easily understand process and remember taught information. There are many advantages of these technologies, such as collaboration capabilities are improved, the learning process is becoming more practical, the learning place is safe, learning material may be used anytime and anywhere. The next pillar is system integration. System integration is the process of connecting different subsystems, which is component, into a single larger system that function as one. With regards to software solution, system integration is typically defined as the process of linking together various IT systems, services, or software to enable all of them to work functionally together. Next is cloud computing. Cloud computing is the delivery of computing services, including servers, storage, databases, networking, software, analytics, and intelligence over the internet, or called as the cloud, to offer faster innovation, flexible resources, and economies of scale. Cloud computing becomes more and more used in education in general and also in engineering education, and in some cases is replacing the official learning management system. Cloud computing as a solution for cost reduction and administrative efficiency, but also it has raised the concern on data privacy and long-term sustainability. Next is big data. Big data is collection of data that is huge in volume, yet growing exponentially with time. It is a data with so large size and complexity that none of traditional data management tools can store it or process it efficiently. Big data is also a data, but with huge size. Next pillars is Internet of Things, or it's called IoT. Internet of Things is network of physical objects or things that are embedded with sensor, software, and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet. The next one is 3D printing. 3D printing is a process of making three-dimensional solid object from a digital file. Next one is cybersecurity. Cybersecurity is a practice of defending computers, servers, mobile devices, electronic systems, networks, and data from malicious attacks. The next pillar is autonomous robots. Autonomous robot is the intelligent machines capable of performing tasks in the world by themselves without explicit human control. As we know, autonomous robot can be implemented in education. They are used in the educational process to improve and facilitate the learning activities and to improve the student performance and result. The applicability of robots in the education emphasizing the main advantages of their use. A specific category of robot is represented by those robots that are designed to support the teacher's activity in the class or to teach part of curriculum to the student. Several studies have shown the students become more engaged in the learning process, even for science, technology, engineering, and mathematics STEM subjects after the use of this autonomous robot. The last one is simulation. Simulation is a model of a real activity created for training purposes or to solve a problem. For education, there are many simulations that we can use. Some of the simulation that we can use is computer-based simulation. Provide students with the possibility to observe and experience real situations and scenarios. Based on this, it will be easier for them to assimilate and to combine the information with the knowledge that they already have. Regarding the engineering education, computer-based simulation can complement, extend, and in some cases to take place of the conventional element. Computer-based simulation for the design project in an electrical engineering course. This educational platform has led to a new learning concept named flipped or inverted learning. The characteristic of this new way of learning is that the learning directives are provided through media files such as video, pictures, text, and animation, and the time spent by the students in class is mostly used for a better understanding of the course content, for discussing with teachers and peers, for debating and solving problems. It is proposed a combination of flipped and blended learning in order to enrich the learning process for engineering design courses. For the conclusion, in the IR 4.0 vision, the learning process is much related to the learner and his need, taking into account also the personalization of the learning process. In this context, the adapting technologies for enhancing learning in engineering education can be a very good solution to create the framework that the student need. Taking into account the mentioned question, the technologies offer answer and alternative for most of them. For example, delivery method for the educational content, teaching approach, collaborative work, knowledge enhancement, location, industry requirement, and job-specific knowledge. The technologies, along with their specific method for enhancing learning in engineering education, represent a big step forward for the education process. A new, interesting, and complex approach of the learning process is built. This approach being associated with specific strengths, weaknesses, opportunities, and threats. That's all from me. Thank you.